Good morning. Thank you for attending our real-world IP seminar. We've got people from all over today, apparently. We have some guests from Sweden. So thank you for traveling so far into London on this morning. If it's anything like the airline yesterday, you should be lucky you got to London instead of Edinburgh. But that aside, so today's seminar is we have 5 speakers. We have Paul Harding, who will be talking to us shortly from NEP. And what we want to achieve is show you a real-world working example of SD2110, and then have vendors show how they made their particular part of these systems work. So the idea is we're trying to train and educate and help you along the way. My name is Tony Orme. I'm the editor of the Broadcast Bridge. I'm actually a broadcast engineer by training. I started my career some 30 years ago working at the BBC, and I've worked in various engineering capacities since then. I also lecture at the University of Surrey, and I teach on the broadcast engineering course there and teach video fundamentals. And one of the things we constantly teach the students is about backwards compatibility. And even now, 80 years after television was first invented, we're still talking about line syncs and frame syncs and field syncs and blanking. And SD2110 helps us move on from that, and I'll talk about that in a little while. So at 9:45, we've got Paul, who will be speaking shortly. And then at 10:30, we have Daniel Bolt from Meinberg, who'll be talking all about timing and PTP. And if we throw away the line syncs and the frame syncs, we have to replace it with something. 11:45, we've got Jared Phillips from Arista talking about network topologies and Ethernet switches, with a lunch back in the main room where we were a few minutes ago. And then at 2 o'clock, Choosing the Right Equipment by Phil Myers from Lavo, and Integration by Norbe Paquet from Sony. We'll have a bit of a coffee break, and then we've got our panel discussion just before we have retired back into the main room for coffee, drinks, and a bit of a chat. So our objectives are, by using a real-world example, understand from leading industry experts and vendors how to make SD2110 installations work reliably and efficiently. And the devil is in the detail. The words reliably and efficiently. And we'll talk about more of those as the day goes on. So why is SD2110 so important? I truly believe that 2110 is the most important advance in television since John Logie Baird went head-to-head with EMI Marconi in the BBC's 1936 trials in Alexandra Palace in London. And the reason I believe that is because SMPTE have abstracted away the video, audio, and metadata essence from the underlying hardware. In other words, they've thrown away the core timing that we've been used to for the past 80 years, that is line syncs, field syncs, framing, blanking. All of that information that we used to have is essentially being thrown away. So that frees us up because no longer will we be dependent on point-to-point dedicated connections. And no longer will we be constrained by fixed, non-scalable hardware systems. So what problem are we trying to solve? What is IP all about? Why are we moving to IP? Well, essentially, essentially, we want to improve workflow efficiencies. Reduce costs. Reduce costs is an interesting idea because the equipment, the kind of equipment we have to use in IP in SD2110 is not the kind of equipment that you can get from your standard IT high street supplier. This is seriously high-end equipment, which comes at a cost. But what we do get is flexibility and scalability. And the idea is the flexibility and the scalability make up for the costs. So technically, we're reducing costs. So how do we achieve this? Well, first of all, how don't we achieve it? We don't achieve it by just replacing the acronym SDI with IP. If you do that, then we're going to have some interesting challenges. You're not going to get the economies of scale that we've spoken about so far. It's about leveraging dynamic networks. It's about automation, and it's about scaling resource to meet demand. So what are we familiar with? Traditional distribution assumes the underlying network is error-free. It's almost error-free. It's error-free enough. Latencies are easily defined and are usually very low. And systems are predictable and static. But many of us have worked in TV stations where you finished an installation and within 10 minutes, the people in MCR are ripping out the U-links and replacing various bits with patch cords. But what is different about IP? IP packets are unreliable in their distribution. And really, I suppose I should change the word unreliable with non-guaranteed. Because we can't guarantee an IP packet is going to get from a camera to a monitor or a microphone to a sound desk. So we have to be creative about how we guarantee those packets are going to get there. We've got two options. We either put an extra layer of protocol over the IP so that we can guarantee delivery, and we call that TCP. And that's how OTT works. But with that, we incur lots of latency and some unintended consequences. Or we improve the quality of the network so the packets stand a better chance of where they're going to. So in studios, we tend to focus on improving the quality of the network, whereas in OTT, we tend to focus on reliable delivery systems, like TCP and HTTP and Dash and all those things. Latencies are difficult to define and do vary. So in an IP network, you're going to find that the latencies can change depending on the topology and the design of the network. Systems do self-heal, and they can fix themselves. So if a switch or a router dies, depending on the configuration of your system, the system can repair itself, but that does have a knock-on consequences. And the important thing here for me is that networks have their history in banking and the military. Because IP was originally designed to work for the military with ARPANET, and then the banking industry used it to start distributing information for their banking systems. So the way IT people think and the way broadcast engineers think are completely different mindsets. And that's something we have to acknowledge and work with. And I did this with my writing with a broadcast bridge. I actually have written 2 books. The first one was Building Media IP Facilities, and that's how to teach broadcast engineers to do IT. And the second one was Broadcast for IT, which is how to teach IT engineers to do broadcast. And what I'm hoping is that the two will join in the middle. And after my experience of working with both broadcast teams and IT teams, that is definitely possible. And is happening as we speak. So the solutions. Broadcasting requires placing a synchronous network onto an asynchronous network. So IP is fundamentally asynchronous. And we're trying to put our synchronous video and audio on top of it. We make delivery tasks based instead of time tasks. So instead of having absolute time samples, which have to be perfectly synchronized, we focus on delivery of packets of data. And we make all recorders and players timestamp synchronous. So if we've removed our fundamental line syncs and field syncs and frame syncs and blanking and all the other information we've used in the past, we have to replace it with something. And this is what the timestamps are, and we'll be hearing about PTP shortly and how that works. But the big advantages for me is SD2110 is format agnostic. In the SDI days, it's very difficult to, in the earlier days when HD came in, to mix SD and HD. It was almost impossible to mix US formats with the European formats because of the difference in frame rates. It did develop as time went on, but then we're moving into 3G, 6G, and 12G SDI. But with IP, you can actually put any type of format of data you like on the network because the packets are format agnostic. They don't care. The different formats can be simultaneously distributed over the same network and fiber. So you can put lots of different systems, or lots of different programming and distribution all in the same network. And the really important thing is that we are future-proofing for new formats that are yet to emerge. So if we've thrown away all of our frame syncs and line syncs, we're still reliant on frames of video, our 25, 30, 29.97. But as we advance, we can go to faster and faster frame rates. But what about if we have dynamic frame rates? So instead of having a fixed number of frame rates, we have only frame rates that replicate the motion in a picture. I mean, that's sort of future-proof thinking. I don't know anybody who's doing that yet. I'm sure there are people who are certainly researching that. But with IP, that is possible, and that can happen. We've got fast production of developments for software as a service. So if you're a vendor and you want to deliver services, you can do them much faster in software than you could do in the old hardware, especially with the speeds we're looking at the moment for UHD, 4K, and HK. The speeds disappear off the radar as far as building hardware is concerned. And the cost of development and time to market for new products is considerably reduced. So the new pricing models will emerge, and that opens the world for pay-as-you-go and pay-on-demand services, which we're starting to see at the moment. We've got the opportunity to go to virtualization and cloud services. I'm starting to write articles now where vendors actually have virtualized live IP working in on-prem data servers and in cloud servers. So this is happening as we speak. Systems are more dynamic. So in conclusion, SD2110 has abstracted away the underlying hardware from the video, audio, and metadata essence, and I can't overstress how important that is. IP is bidirectional, and again, this is really, really important because in broadcasting, we're used to just sending data in one direction as a fire and forget. But now we have the opportunity to receive data coming back the other way without any overhead of cabling. IP provides easy connectivity to data centers and the cloud. It's really difficult to get SDI into the cloud without going through IP first. And as I'm reminded, there are no GPIs in the cloud. It's strange that we're still using GPIs, but they still form the backbone of quite a lot of TV installations. And virtualization and generic networks have removed the antiquated and restrictive hardware models of operation. So if you want to read more about IP and how IP works, please have a look at my articles. I've counted them up the other day, and I've written something close to 150 articles for the Broadcast Bridge on IP and how to make IP work.